Hello and welcome to this video on how to use GPower to calculate the sample size and also the power you achieved for ANOVAs. So this video is going to be quite long because it covers quite a lot of different ANOVAs, and what I would suggest you do is you watch the first maybe 8 minutes or so up until the point where I start showing you different examples, and then you can skip to the example you're particularly interested in. So that means that instead of watching a 35-minute video, which you're more than welcome to do, it should save you some time. I should also explain that this video is going to focus on have two halves. The first half is the part that I spend most of the time looking at, which is about looking at how you would calculate your sample size needed for your analysis. So this is a priori, this is before you start your analysis, and is all about working out how many participants you need. Then you've got what's known as a post hoc GPower, which is about calculating the power you achieved. So let's say that you didn't achieve a significant result and you want to know how many more participants you would need in order to achieve that results based on the effect size you got. Then that's when you would do a post hoc. Okay, so first thing to say is this is the link to download GPower. I'll put a link in the description as well, and if you just click here, come down here, and then you can see here is the manual, and then you've got options to download GPower for Windows and download GPower for Mac. You can just click to download it and then just wait for it to download. What you'll see is you've got a folder in there, and then you just want to go and install it like so. It's quite a small program, so it doesn't take long to install, and likewise it's the same for the Mac as well. So that being said, let's go back onto here and let's look at some key terms. So the first one is effect size. So effect size is a measure of magnitude, and the thing about an effect size is it's independent now from sample size. Now there is a caveat there, which I will come on to later, to do with kind of the stability of the effect size and how, if you've got a very small number, it wouldn't be very stable. But generally speaking, the effect size is just a measure of magnitude of the effect. So let's dig down a bit more into that. So if we take, for example, Cohen's F, which is the effect size we're going to be focusing on today, because it's the one that GPower tends to use. Cohen's F is calculated by looking at the differences in the means, and the bigger the differences between the means, the bigger your effect size. You've also got power. Now power is the probability that the test you're doing will find an effect, assuming that one exists. So this is what's known as avoid making a type 2 error. So in other words, you don't wrongly accept the null hypothesis. So the more powerful the test, the more capable it is at finding a difference if there is one there. And then finally, Cohen in 1992 recommends that you choose a power 0.8 when conducting a priori sample size calculations. So when you're kind of looking at how many participants do you need, use a power 0.8, and that means you've got an 80% chance of finding an effect if one exists. Okay, so I wanted to kind of show you the relationship between effect size and sample size. So as you can see, as effect size increases, the number of participants you need in order to achieve significance goes down, and the reverse is true. So equally, if you've got a really small effect size, then you will find that you'll need loads of participants. So ideally you want as large a kind of effect size as possible. Now this is just picking up on what I said earlier about the stability. So what you can see is this is about the range of effect sizes you get. So if you've got very few people, you will find that you get very wide variations in effect sizes. So in other words, if you've only got like 5 people, you probably can't trust your Cohen's F statistic, or you can't trust your partial error. But the more people you get, the more stable the effect size becomes, so the more you can trust it. So while effect size is independent of sample size, there is still some relationship in terms of whether you get a stable result or not. Okay, so the key one, or the key effect size I will be using throughout, is Cohen's F. So Cohen's F is just a measure of the differences in effect size, and the key values you want are to bear in mind that 0.1 is a small effect, 0.25 is a medium effect, and 0.4 is a large effect. And Cohen said in 1988 on page in his book on page 285 that if in doubt, go for medium effect size. So if you can't find an effect size based on previous literature, then just go for a medium effect size. So one of the problems, or one of the challenges you might find, is that not all papers will report a partial letter value, or will report a Cohen's F, at which point you might need to convert the effect size. So here is a handy dandy spreadsheet which you can go and load up. And here we go. And what you can see is it gives you various different input types. So if, for example, someone's reported a R value, you can go under here and you can enter in the R value here. So let's say that they've generated an R value of 0.6, for example. And what you can see is that it will give you alternatives, including Cohen's F here, for converting the effect size. Word of warning, use your common sense when converting it. So sometimes you'll get a spurious, kind of very large partial letter, or you'll get a very large S² value. And when you go to convert it, you'll find that it gives you a massive R value or a massive F value. So just take it with a pinch of salt and just make sure that you've not got some sort of spurious result. Just kind of eyeball it and go, does that look sensible? You know, is it possible that you've got an effect size of 1? And the answer is probably not. And then if you just want to move between them, you just click there to change it. So you can look at papers and you can convert effect sizes that way. And I will of course put a link in the description of this video discussion section. Okay, so the general structure of reporting GPower. So you'd say something like the following. So in a priori GPower analysis was conducted, the reference for GPower, which is actually taken from the website as well. And based on effect statistics, so this is where you'd say something like partial letter or Cohen's F. And then you'd say taken from this paper here. So you'd say what the effect size was, and then you'd say it was taken from this paper. And a power of 0.8 in line with Cohen's 1992 guidelines, it was determined that for say a ANOVA, or a one-way between subjects ANOVA, or a two-way between subjects mixed ANOVA, or whatever, it was found that with this number of IVs and this number of levels, you would need a total sample size of this number, and you might even say, and this would be split into 3 groups of 20 or whatever. Yeah. And then you've got the reference for Cohen in 1992, and you've got the reference for GPower. So at this point, I would advise you to have a skip around and look at some of the examples. So you don't need to watch the whole video. You can just skip to the relevant part that you're interested in. Throughout this, when I've tried to use a previous paper, this is just a paper I happened to kind of stumble across. I think it's actually a master's dissertation, so it's probably not great, but it just happens to report partial letter for optimism, which is what most of the examples are based on. It also has the advantage of being open access, so that's why I've chosen it. And the one thing that I want to show you here, if I come over here, you can see that he's reported a partial letter of 0.196. So for those of you who are familiar with your partial letters, you'll see that this is a very large effect size. And what I wanted to do was draw this comparison between what happens when you've got a large effect size and what happens when you've got a medium effect size. Often you won't get such a large effect size, but in this case we have them, so that's great. Okay, so on with the examples then. So a priori, so let's start off with a one-way ANOVA between subjects, and I'm using, it's on page 261, this example of Pallant. So if you want to have a bit more information about the example, you can go and read that. But essentially it's comparing levels of optimism for young, middle-aged and old people. all participants to see whether there's a significant difference. So for a between subjects ANOVA, what you would typically want to do is the following. So let's go and load up GPower. And we're going to F-test, which is where most of them are based. Come down here and we want to go for fixed effects omnibus one way. And we want to say, so his partial letter was 0.196. So we go there. We come down here, we go effect size from variance, we go effect size from variance, we go direct, and we go for 0.196. Calculate and transfer to main window. We then want to change that to 0.8, and you'll see this being a running theme throughout. And we've got three groups because we've got young, middle-aged, and old. And then you click calculate. You can see that we need 45 participants. Right, if I was to change that though to a medium effect size, which is 0.25, you would see that it jumps all the way up to 159 participants. So by making sure that we've got a large effect size, we've saved ourselves a lot of work in potentially recruiting for participants. So that's good news. So let's look and see how we would report this. So come here, and I'm just going to zoom in, and I'm also going to get this on the other screen. Okay, so you can see that a priori GPower analysis was conducted, reference for GPower, and based on a partial letter of 0.196 taken from the reference that we found, and a power 0.8 in line with Cohen's 1992 guidelines, it was determined that for a one-way ANOVA between subjects with 3 levels, you would need a total of 45 participants. Okay, so that is the between subjects ANOVA. So let's move on to the within subjects. Okay, so in this particular example, we were looking at the changes in statistical confidence over 3 time periods. So just before an intervention, just after an intervention, and then I think 3 months follow-up. And the way we would do this is we would do the following. So we want to get ANOVA, and we want repeated measures within factors. We want to change that to 0.8. We want to say the number of groups being 1, because we've only got 1 group. We want to say the number of measures being 3, because we've got 3 time points before, after, and 6 months later. We don't want to worry about the correlation amongst the measures. That basically allows you to, if you know some of the measures in your population, to kind of control for that. Then we click calculate. You can see that we get 28 participants. So if you look at how we would report that, we would say an a priori GPower analysis was conducted, reference for GPower, and based on a medium effect size and a power of 0.8 in line with Cohen's 1992 guidelines, it was determined for a one-way ANOVA within subjects with 3 levels, you would need a total sample size of 28. So just to point out that was set onto a medium effect size, which was 0.25. Okay, now we move on to the between subjects. So in this example, we've got it's a two-way between subjects. So you've got gender, which has 2 levels, and you've got age group, which has 3 levels. 18 to 29, 30 to 44, and 44 plus. So one thing I want to do before setting this up is show you how to use the numerator DF. And you can see that the way we calculate the numerator DF is we take each condition, we take away 1 from each condition, and then we times the conditions together. If we had 3 conditions, we would also times the 3rd condition with that. So in our example, we've got gender, which has 2 levels. We take away 1 from there, so that gives us 1. We've got age group, which has 3 levels. Take away 1 from that, that gives us 2. And then we would do 1 times 2 equals 2. And that's how you calculate the numerator DF. So what we want to do is we want to go and configure this correctly, and because it's a between subjects, we want to go for fixed effects, special main effects and interactions. We want to go and change that to 0.8, and then we want to go and enter our numerator df as 2 because we've calculated that. Number of groups, so let's think about how many groups we've got here. So we've got 6 groups because we've got 3 groups in age and 2 groups in gender. We make sure that that is set on 0.8, we click calculate, and then we see that we've got 158. So you can see that that is a lot of people just by using a medium effect size. But if I was to say give it a large effect size, so 0.4, you see that that jumps down to 64. So the larger the effect you can get, why it's not so. So you can see why it's not so good to just use a medium effect size by default. Okay, moving on. So this is how I would report it. And in fact, what we've done is I need to go and calculate it based on not having a medium effect size. So let's go and do that. And let's go here. Let's go direct and let's enter in 0.196. Calculate and transfer to main window. Calculate 43. So what we would do is we'd say a priori GPower analysis was conducted, reference to GPower, and based on a partial letter of 0.196 taken from the paper there, and a power of 0.8 in line with Cohen's 1992 guidelines. It was determined that for a two-way ANOVA between subjects 2 by 2, you would need a total sample size of 43. And then we give the reference for Cohen, we give the reference for GPower, and we give the reference that the effect size was taken from. So next we've got a within subjects design, which was taken from the SPSS for psychologists, which is available as a ebook should you be interested. And in this particular example, we were looking at whether people tap with their left hand or tap with their right hand. So that's the first IV. And also whether they were performing a memory task which involved memorizing words or memorizing positions. And I think the idea was that if you were memorizing positions, you'd be affected by tapping with your right hand because it's to do with lateralization in the brain. Okay, so let's go and set this up. So if we go analyze, we go repeated measures within factors. And we say number of groups being 1. Number of measures, well, you've got 2 times 2, so that's 4, because you've got whether they're tapping with the right hand or left hand, and whether they're memorizing words or spatial positions. Click calculate, and then if we come down here, so let me just talk you through this. You can see that it's a 2 by, you'd say something like the following. So an a priori GPower analysis was conducted, reference to GPower, and based on a Cohen's F of a medium effect size, which is what we've got there, of 0.25, and a power 0.8, in line with Cohen's 1992 guidelines. It was determined that for a two-way ANOVA within subjects and a 2 by 2 design, you would need a total sample size of 24, and then your 2 references. Okay, so that's the within subjects. So let's move on to the two-way mixed ANOVA. And in this specific example, we're looking at the difference between a intervention where you've got a maths intervention and a confidence intervention to see whether you can get people to reduce their maths anxiety. And you've got 3 time points, so you've got before, after, and then 6 months after. And we're also basing it on a different paper. So in this specific example, we're basing it on this paper, which had a partial error of 0.150. So what we're going to do is we're going to set up the mixed one. So what we want to do is go down here and go for repeated measures between factors. We then want to change the number of groups to, and the number of measures will be, well, we're measuring those people twice and those people 3 times. So 2 times 3 is 6. We're going to change that to 0.8. and we're going to go here and we're going to calculate it based on a partial eta of 0.150. We're going to click calculate and transfer to main window. You can see that once again we've ended up with a large effect size. So with that in mind, if we click calculate, you can see that we would need a total sample size of 30. So if we go and look at how we would report this, we would say a priori GPower analysis was conducted, reference to GPower, and based on a partial eta of 0.15 taken from the reference here, and a power of 0.8 in line with Cohen's guidelines 1992. It was determined that for a two-way mixed ANOVA mixed subjects with a 2x2, you would need a total of 30 participants. Okay, and then you've got the reference again for GPower. Okay, so next we move on to ANCOVA. So ANCOVA is where you control for another variable. So in this specific example taken from the SPSS Survival Manual, we're controlling for people's pre-test scores. So we've got a similar design before where we're doing a pre and post tests on people who are suffering from fear of statistics and having an intervention, and we're seeing whether with a pre and post test and controlling for their initial scores, whether that makes a difference. So to do an ANCOVA, you would come down here, you would go onto here like so. We're just going to go for a medium effect size for the time being. We're going to change that to 0.8. We're going to say number of groups will be the following. So you've got confidence building and you've got the other one. So we're going to say 2. And if we come here, going to do the following. So we're going to say number of levels of the IV is 3 psi. So there are in fact 3 groups. And we're just going to do 3 take away 1 gives us 2. So that will be our denominator. So yeah, 2. We'll go there, and then that should be 3. Click calculate and transfer to main window. You can see that with one covariate, you need 158. If we think about how we would report this, you would do the following. So you would say a priori GPower analysis was conducted, reference to GPower, and based on a Cohen F medium effect size and a power of 0.8, it was determined for a one-way ANCOVA between subjects with 3 levels, you would need a total of 158 participants. So just to kind of recap that a moment, the reason why it's 3 levels is you've got before, after, and then the follow-up, where you've got a control. Okay, so what we're now going to do is we're now going to look at the post hoc. So the post hoc is conducted if you've not achieved significance, and it's worth saying that GPower can do a post hoc power calculation for any of the tests that I've just shown you, but we're only going to focus on the example of between subjects ANOVA. So in this example, I've just taken some of the first 20 participants from the SPSS Survival Manual's survey.sav dataset, and we've just got sex, age group, and total optimism. Could be total mastery, but I'm not sure. It's one of those. And what we're going to do is we're just going to run the ANOVA very quickly. Going to click OK, and you can see it gives us the ANOVA, and it also gives us a partial eta. Now, if you want to know how to request that partial eta, what you would do is you'd go onto here, you'd go onto options, and make sure that estimates of effect sizes are selected. And what we can see is that we've not achieved significance in any way, shape or form in any of them because we've only had 20 participants. What we would do is we would take one of the partial etas here and we would see what power we actually achieved. So in this specific example, we would go for, let's load up GPower again. Let's go F-test. Let's go for the right one here, which is that one. Let's change that to 0.8, but we'll come back to that shortly. And let's go down here and choose post hoc. And this is how you get to post hoc for whatever you do, basically. We then enter the number of participants we had, which was 20. We then enter our effect size that we achieved. So we need to go to determine direct, and we need to enter in 0.069, calculate and transfer to main window. You would then go and calculate your numerator. So to calculate the denominator, we would go age group. We've got 3 levels there, 2 in there. So 3 take away 2 is 3 take away 1 is 2, and then sex is 1. So we're doing 2 times 1, which is 2. Number of groups, because we've got 3 age groups and we've got 2 gender groups, that would give us 6. And then we click calculate, and you see that we achieved a power of 0.15. So obviously we'd be aiming for a power of 0.8. So let's go and see. If we go back here and we go and change this to a priori, you'll see that it saves most of the details. And then all we would do is we'd make sure that that was 0.8, and then you would see that you would need 134. So if you're wondering how to report this, you'd probably say something like the following. So we would say, as the ANOVA was not significant, a post-hoc GPower calculation was conducted, reference to GPower, and with a medium effect of 0.27, which is there. So we calculated based on our partial error what that was. In order to achieve significance, you would need a sample size of 134 to achieve significance at a 0.05 level. So an extra 112 participants would be needed to achieve a power of 0.8. The current study achieved a power of 0.15. And that's how you would report a post-hoc analysis for if you don't achieve significance. It's worth saying that all of these, if I just show you, so if we go for, I don't know, the ANCOVA, you can all see that all of these have the option to do post-hoc, and it works roughly the same way. So that concludes this video. Hopefully it's been useful. Hopefully you've not watched the whole thing and you've skipped around. But if you've got any questions, please feel free to email me on c.hickton@newman.ac.uk. Thank you very much.